exponential and logarithmic functions. In this video, we are going to focus on logarithmic functions. This is part C in the video series, Exponential and Logarithmic Functions. Now we'll look at a new law called the logarithm quotient rule with restrictions. For the given expression to be defined, both logarithmic terms must be defined. To determine the restrictions on the variable, consider each expression and set each one to be greater than 0. Here is a sample. Identify the restrictions on the variable in this given expression. The log of x squared plus 7x plus 12 divided by x squared minus 9. Now, in order to determine restrictions, you must factor each term. So if we take a look at x squared plus 7x plus 12, we must find two numbers that multiply to give 12, but add to give 7. We find those numbers to be x plus 4 and x plus 3. Now we're going to look at the denominator, x squared minus 9, and that will give us x minus 3 times x plus 3. Now that we've done that step, we're going to look for common factors top and bottom and cancel them out. Then we'll determine the restriction. So x minus 3 has to be greater than 3, which means that x must be greater than 3. Now, we're going to take a look at one more thing. And in this, we're going to look at how to solve an equation where one side has the log value and the second side does not. Here is our example. Log base 5, bracket, 2x minus 3 is equal to 2. To solve, we're going to rewrite both sides in exponential form with the same base and solve. To do that, we're going to take our expression. We take the base value from the left side and make it as the base on the right side. So we get 2x minus 3 equals 5 to the exponent 2. We now solve the exponential part of the equation. 2x minus 3 is equal to 25. And it becomes a simple equation we can solve. Bring the negative 3 over becomes plus 3. 2x is equal to 25 plus 3. 2x is 28, and x is equal to 14, which is 28 divided by 2. Now, let's move on to solving some logarithmic equations. Remember, help is only an email away.